In this video, I will show you how you can quickly solve a Windows boot delay, even if this one doesn't seem easy to troubleshoot at first glance. Hi everyone and welcome to my YouTube channel. First of all, if you are new to my channel, click the subscribe button and hit the bell icon so that you get notified when I release new videos. Let me explain the case. A person who owns an Asus laptop decided to replace his small SSD disk with a bigger one. So before he makes the replacement, he has cloned his old SSD on the new one. He plugged the new SSD disk, starts his laptop, the Windows logo shows up and it remains displayed for 2 minutes before the boot continues. After Windows started up, everything was working fine. First, this person thought that maybe the new disk has a problem, as it was the only thing changed in his machine configuration. So he tested the disk health and it was good. So he made a boot trace and he sent it for analysis. Let's examine his boot trace and try to identify the delay cause. The first thing I will look at is the boot phases graph to see in which phase the delay happens. This graph shows the different boot phases and their duration. Up front, you can see that the PresessionInit phase is longer than the other phases. The duration of this phase is 121 seconds, which equal to 2 minutes. Usually this phase takes a few seconds. This phase consists of loading and initializing drivers. We will focus our investigation on this phase. I will select this phase and zoom in to get rid of the other events occurring in the other phases and focus my analysis only on the events occurring in this phase. My next step will be the use of the generic events graph that contains all events that occurs during this phase. At the left of the gold bar, there is the provider name column. For the sake of simplicity, let's consider the providers as a group of similar events. For example, events related to the prefetch system are grouped in Microsoft's Windows kernel prefetch. Events related to the plug-and-play drivers are grouped in Microsoft's Windows kernel PnP. In our case, I will look at the plug-and-play provider that contains operations starting at the system precession phase and consisting of loading and initializing drivers. I will briefly explain the other columns so that you can understand where you should look at to identify your culprit. The task name column contains the nature of task. You can see here the OS loader task, and just after we have device enumeration task. The opcode name column represents the task state. For example, for the device enumeration task, it can be started or stopped. The process column contains the name of the process originating the task. Here we have the thread ID, and we have many others columns that contain others information depending on the selected provider and task. Just here we have the time column. It contains the time at which the action were performed relatively to the trace starting time. For example, the OS loader task started at 0049 seconds. Now I will scroll down and keep an eye on the time column to find this gap in time equivalent to the delay observed earlier in the PresessionInit phase. Yes, here it is. Look at this. There is a jump from 0.28 seconds to 120 seconds. This is the delay we have observed in the boot phase graph. But now I need to find more details to identify what was causing the delay. Here we have the task performed during this delay. It's the device start action. It seems like the OS tried to start the device during 2 minutes. The opcode column showed that the same action started at 0.28 seconds and stopped at 120 seconds. Here we have the process responsible for the action, which is the system process, and its thread number 8. Now I will scroll to the right to see the driver name column. And the driver that was performing the action is this kind of long ID that doesn't mean anything for me. So I need to decode this ID and get the driver name in a readable format. To go faster, I will just copy the ID. I will open the trace menu and click on the trace properties. Next, I will click on the PMP for plug and play. In this table, the first column contains the device ID. The second one, the device description. And the last one, the device friendly name. To find the device I am interested in, I will just right-click on the device ID column. In the context menu, I will click on Find in column and paste the ID I have copied earlier from the generic events table. And click the Find button. Here it is. I have my device ID here, and in the device description column, I can now clearly identify the device, which is Intel Series Chipset SATA controller. The Intel Chipset SATA controller manages the communication between the processor, the memory, and the disk. Does that mean that Intel controller is failing? No. Why? Because the same controller was there before the disk was changed. So we have excluded the disk and the controller. So who is the culprit? It remains one suspect, the driver. And this driver is Intel Rapid Storage driver. How I know that? Experience and many similar cases I have solved. But even if you are a beginner, I will show you how to identify the driver. If I go back to the generic events graph, I can see the driver name shown in the task boot init, executed just before the device starts task. To be certain this is this driver, I will use the CPU sampled graph that will show me what the process were doing during this time. Let's change the view to add the thread column. Now I will drill in the call stack of system process thread 8. Remember that the generic events graph shows me the process and thread that performed that device start task. System process and thread 8. Now back to the CPU sampled graph and start drilling the call stack. Let's show the hidden columns. The wait in view column shows the time spent in milliseconds by the thread in the CPU. And you can see that the thread 8 spent 120 seconds executing code in the CPU. So the principle is pretty simple. I will keep drilling in the call stack till the end. Then note the name of the last driver I see. Here I have storeport.sys driver. This is the Microsoft generic driver that allow application access storage devices in case there is no specialized driver. I will keep drilling. And here I have the IA-store-A.sys driver, which is the Intel Rapid Storage driver. I will continue drilling to see if there is other drivers involved. Here I reach the end of the call stack when I see the HAL.dll module, which is the hardware abstraction layer. And sure enough, the last driver involved is Intel Rapid Storage driver. So now that we have the culprit, what is the solution? In most cases, updating the driver will solve the problem, but not in this case. The driver was already up to date. The solution was uninstalling, then reinstalling the Intel Rapid Storage driver. I suppose that when the user cloned the old SSD disk on the new one, the Intel Rapid Storage driver kept working with the specifications of the old disk. That caused the delay of 2 minutes when using the new disk. In this example, I showed you how it can be fast to identify a boot delay issue that can be difficult to troubleshoot in the conventional way, simply by using Windows Performance Toolkit and a bit of logic.